Hello guys, welcome back to class. So in the previous session, we understand what are AVL trees and what is the balance factor and how to do the four types of rotations with AVL tree whenever it is becoming unbalanced. We have seen four types of rotations: LL rotation, RR rotation, LR rotation, and RL rotation. So we'll see some more use cases on that. We just considered the rotations by taking three values previously. We'll take a more values. For example, my keys are now, I'm taking a different set of keys: 60, 70, 50, and 40, 55. These are my keys. So take the first use case. Insert all of this. Insert all of this. So first 60. Yes, there's a root. 70 greater than means comes to the right side. Next 50 less than this comes to, so as of now it is balanced. Next 40 means less than this. So tell me, up to this is a balanced or not? And 55 also, like 55 didn't. So 55 means root is 60, 55 less than, come here, 50 greater, 55 is greater, so this comes here. So I inserted all this. I think these elements, whatever I got, automatically it is balanced, right? I didn't do any rotations. And whenever I insert a 60, 70, 50, 40, 55, we didn't get a unbalanced BST at any point of time. Okay, up to this, fine. Now, I am inserting 30. I'm inserting 30. So where 30 will come? Where 30 will come, guys? 30. Left of 40. Okay. Here is the 30. Now see, I think whenever I insert 30, I am doing. So whenever I insert 30, which comes as a left of this, I think now tree becomes unbalanced, right? It becomes unbalanced. If you see the, this is 0, this is 0, this is 0, this is 1 minus 0, 1, this is 1, 2, 2 minus 1, 2 minus 1 is 1, this is 1, 2, 3, 3 minus 1 is 2. 60 becomes unbalanced. 60 is the unbalanced node because balance factor is 2. Now tell me, which element inserted to which is unbalanced. So start from that 60, you make it as 60 left, again 50 left, again 40 left. It is L, L, L. But we got a 3 L's, right? From 3 L's, you take only the last, this two only. So what is this rotation now? What is rotation we need to do on this? Because of 30, we got a situation to do the LL rotation. We got a situation to do the LL rotation. Okay, so now do this carefully. LL rotation means which side I have to rotate? LL rotation, which side I have to rotate, guys? Rotate towards the right. So it should go like this. It should go like this. And which is three nodes you have to consider mainly? Which is three nodes you have to consider mainly? Which is, I told you, only when you do the rotations, we'll take three nodes in mind. Only three nodes will impact. Only three nodes you have to keep in mind. Which is three nodes I have to consider. Like a previous, you take 10, 20, 30, I have taken three only. But this is a big tree, it has many. Maybe here, your 70 can have some subchilds, 55 can have some other childs. We don't know that. We don't know that. Let it, it has something. For example, 55 has some X and Y. Numbers I'm not taking, let it be. And 70 having some P and Q. some numbers which are according to the tree. Consider like this. Those keys I didn't take here. So we have to do LL rotation. We have to shift towards the right side. Tell me what happens. So shift towards the right. Right, you're doing. So what becomes the root, guys? So you consider only 40, 50, 60, like your 30, 20, 10. 30, 20, 10 we have. Previously, same case. You consider only this, and this, enough. These three, here is the 40, 50, and 60. Keep these three in mind. These three, like in our previous case, we have a 10, 20, 30. We are doing this rotation, right side. So what becomes the root? In our case, we done a 20 as a root, right? 20 and 30 this side and 10 this side. So similar means 50 becomes, here is 50 becomes a root, 60 this side, 40 this side. Clear? So always the previous rotations keep in mind. Now tell me what is the root? Root is 50. That is super clear. Now for 50, what is the right child? 50, what is the right child, guys? 50, what is the right child? No, you should not do like that, Abdul. 60. See, the parent automatically comes to this. 60 is the right child. 60 child remains the same. 60 child remains the same. 60 child is 70, which remains the same. 70, if any childs are there, 70 has a P and Q. Those remain same. You are not touching anything. Clear? Now, what should be the child of 50? 50 child is already 50 child is. Yeah, we'll come back to that. 55. What is 50 child? Tell me. 50 child is 40. 40 child is 30. Okay. Now, what is the 50? Previously, 50's parent is 55 is there pending. 55 previous parent is 50, but 50 already got the two childs. So 55 where you have to keep. Will it sit in the right side or left side or right side? 50. 50 should go to the right side. All 50 should go to the right side. The right side means 60. Any space is there? Yes. 60 less than 55 less than 60. So this comes here. This is the one important point to check. Is this clear? And 55, if any childs are there, for example, X is there and Y is there, those remain same as it is. Is this clear? Yes, Bikash, what's your doubt? That is, you can take anything, because question is why you taken 40, 50, 60. I have taken 40, 50, 60. Because I started from 60 mainly. Which node is unbalanced here? Tell me. Here I've taken 60, 50, 40. 60, 50, 40. So which is the unbalanced? 60. So I'm taking from 60 only. I'm taking from 60 only. So we need to have some remark, right? We know that the low balance factor of 60 is 2. So that you consider, from that you take 3 nodes. Always 3 nodes will consider. So is this clear, guys? How it is happening? XY, PQ I just considered. So if any, it can have any subtree. The remaining subtree makes as it is. Your rotation makes only 3. We have to start from unbalanced node. Okay? Is this clear, guys? Okay. Again, the same keys I am using. See this. See this. Same keys I am using, creating. Same keys. Okay, 60 inserted. Then 70 coming on the right side. Okay. Then 50 coming, 50 coming on the left side. And 40 goes to this side. Then I have 55 comes to this side. Your 55 can have anything like as I drawn the above. 55 this is, sorry. It can have X and Y other childs. 70 can have P and Q other childs. Again, X and Y can have other subtree. P can have a subtree. Q can have a subtree. It can be a very big tree, no problem for us. Okay. So with the same set of keys, this is a tree as shown as it is above. But this time I am inserting 45 now. Guys, see this. I am inserting 40, previously I inserted 30. Now I am inserting 45. So where 45 will go? Where 45 will go? Where 45 will go? Right of 40. Wonderful. Here, right of 40, we got a 45. So you tell me, guys, now I think tree becoming unbalanced. Now tree becoming unbalanced. Which node is 45 is causing unbalanced, which is becoming unbalanced? I think again a 60 becoming unbalanced. 60 if you take 1, 2, 3 height this side. And currently don't consider this red color PQ and XY. This side you consider 1, 3 minus 1 equals to 2. So 60 becoming unbalanced. 60 becoming unbalanced. Okay. Now from 60 you start. Take the unbalanced 60. 60 onwards you do. This is right. Again right. Next left. So which one I have to consider in this RRL? Which one I have to consider? Sorry, I did a mistake, guys. This is not R. Yeah, this is left side, and right side. So which one I have to consider? LL or LR? As I told here on the top, you consider last two only. The last two only consider. So what rotation I have to do now? What rotation I have to do? I have to do LR rotation. LR rotation is a double rotation, is a two-step process. Is a two-step process. So first left side rotation, then right side rotation. So first do the left side. First do the left, guys. So left means what to do now? This 45 left side, it has to go like this, right? Go like this. Okay. Now in this case, because previous my answer is different, this time is different. This time, which three nodes I have to consider? Which three nodes I have to consider? Which three nodes I have to consider? You consider 50, 40, and 45. 50, 40, and 45. So, like you taken previously, same 10, 20, 30, how you done LR. So, after this, what is the tree, guys? 60 remains there only, which has 50 and 70 also same. That PQs, if any, will write it later. If you want, you write it. Just to show, you may have as other big subtree, but it won't consider. Next, 50 childs. 50 childs. Here is the 55. And it has something called X and Y. Currently, keep like that. Next, when you do the left rotation, what happens? What should be child of 50 now? What should be child of 50, guys? It is 45. 45 is child of this. and 40 comes here. One rotation is done. Now you do the right side rotation. When you do right rotation, always remember, guys, when you do this second rotation, this is the R1, this is R2. So when you do this main, this is the main. And this case, you consider from unbalanced. Consider from unbalanced. Do like this. Right side I am doing. So now it becomes 50 becomes the root. 50 becomes the root. And down to this 60 will be there as it is. 70 will be there as it is. And 50 childs are 45. 45 childs are 40. Now, where is 55? 55 comes down to this only. Next, what is there pending? We got a 40, 45, 50, 60, 70 done. 55 has a child X and Y, keep that, and PQ, keep that. Currently, when you're calculating load balancing, don't consider X and Y, PQ, guys. Just I shown that as a case. So you have unbalanced, I think, right? See, when you're calculating balance fact, don't consider X, Y, PQs. Now, is this balanced? Is this balanced? Two rotations are done? Yes. Do you understand, guys? We're just doing simple rotation. And mostly the time factor of time complexity of rotation is big O of 1 only. But the time complexity of rotation, big O of 1 only. Big O of 1 only. Still because is hanged there only. If you do that, you can try to do that because you try to consider as last three and see how the tree coming, then you come back and tell me. You will get the answer. In some cases, you may achieve it, but in some cases, you may get it complex. That is how, see, if you consider the point with Vikash's, instead of considering these three, making 50 as a root, if you consider 30, 40, 50, then you have to make a 40 as a root. When you make a 40 as a root, and see that, when you make a 40 as a root, what happens? Tell me, guys. 40 I'll take as a root. Then, okay, 30 will be there. Then, so 50 comes here. 50 child, 60 comes here. And 60 child, 70 comes here. See this? What happened? Because okay, what is the ground rule to do it? Let you do conclusion. We'll do the conclusion because. But you understand the problem, right? Now again, it is becoming unbalanced. Again, it is becoming unbalanced. So I'll conclude with the 4 after finishing the remaining 2 rotations. So currently, remember when you do LL rotation, when you do LL rotation, what I have to consider? I have to consider 3 nodes from unbalanced node. That point is clear. When I do LL rotation, I have to consider 3 nodes from unbalanced node, like 60 in this case. Next, when you do LR rotation, we have to do 2 rotations. First rotation, you consider first from impacting node to 3, and second rotation again you take from unbalanced node. Is clear? Same thing we will do it for right and right also. I hope the point is clear, guys. Tell me yes or no. Is that clear? Can I go to the, so we are done here LL and LR guys with the sample data. Okay. Can I go to RR and RL? Now data has to be changed. This key set cannot work for that. So I take a new page. You take a new keys. You take a new keys. So this time I'm using 50 first, 60, then 40, then 55, then I'm using 70. Okay, we have to cause a problem on the right side. So first you construct the tree here. First I'll get a 50. Okay, fine. Then 60. 60 comes right side. Then 40 comes left side. 55. 55 means where 55 will come? Below to this 60. 55. Left of 60 is a 55. Then we have a 70. Right of this is. Tell me, up to this tree is a balanced or not, guys? Up to this tree is a balanced, I think, right? See? Up to this tree is balanced. Yes or no? Say something. Up to this tree is balanced. Yes. So I will insert now. Insert 80, guys. Insert 80, where it has to come? Where 80 will come? 80 will come left, right of 70. Right of 70. Right of 70 is the 80. Yes. Now is unbalanced. Now see the unbalanced root. This is only this is causing, I think. This is 1 minus 1, 2, 3 minus 2. 2 absolute value is 2. This is 1 minus 1, 2. This is fine. So this is the unbalanced. 50 is unbalanced node. Remember, and which is causing unbalanced? 80 is causing unbalanced. So which rotation you have to do? From unbalanced to this, you travel. When you do this, right, right, and then right, 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 3 rights. Unbalanced to a node which is calling unbalanced. We will take last 2 only, RR. So we have to do RR rotation. RR rotation means which 3 nodes I have to consider. Which 3 nodes? RR rotation means which side I have to rotate first? RR rotation, which side I have to rotate? Left side. Okay, draw the diagram like this. Left side you go. Which 3 nodes I have to consider? Which 3 nodes you have to consider? Because which 3 nodes I have to consider? No, then I just now I told you have to take from unbalanced node to 3. Which is unbalanced node here? Which is unbalanced node here? Because Dena, which is unbalanced node? 50 is unbalanced node. From 50 you take 3. From 50 you take 3. 50, 60, 70. These 3 you take. From these 3, which is the middle, 60. So which becomes the root now? Which becomes the root, guys? Which becomes the root? Yes. 60. 60 child is 50. 50 already child is there. 40 as it is. Keep this as it is. 60. And a 60 child we have a 70. 70 child we have 80. But we have 55 remaining here. See? 55 we have to move. 55 is less than this. So it should come here. Is this clear? Now it is super balanced. Very good. Next. Now, next you have to answer. Absolutely, you have to answer. Same set of keys are enough. So first insert 50, done, guys. Next 60, right side comes. 40, left side. 55, left of 60. 55 here. 70, right of 60. This is my tree, which is, I think, balanced. Tell me whether it is balanced or not. Yes, balanced. I want to insert now the 65. I want to insert 65. Where 65 will come? So this is the case I'm taking. Insert 65, guys. Where 65 will come? Left of 70. Wonderful. Do the left of 70. Here is 65. So now you tell me. So here only carefully listen, because you will get your answer. Which is causing the unbalanced? 65 is causing unbalanced. Okay. Which is becoming unbalanced? Which node is becoming unbalanced? I think 50 is becoming unbalanced, because 50 only, this is 1, 1, 2, 3. This is the load balance factor becoming 2 for this. So now, so you start from this. This is the right, this is the right, and this is the left. Which two I have to consider? Last two. RL. Is this RL rotation? RRL, but you consider RL. So this point is clear. Now this rotation is clear, guys. So do the rotation. The first rotation we do right side, and second rotation we do, this is R1, this is R2. Second rotation we do left side. Now first rotation right side. First rotation I do right side. First rotation right side. Now which three nodes I have to consider now? Which three nodes I have to consider now? In the first rotation, which three I have to consider now? 65, 70, 60, because very good, because you are right. So do the right side, guys, drawing the diagram like this you do. Okay. Tell me the impact on the tree. So 50 be there for some time, 40 will be there for some time, 60 comes here as it is, 55 will not change. Am I right? So what change? What is the child of 60, guys? Now child of 60 is your 65 will become child of this. 65 child is the 70. Is this done? Am I right? Right is done. RL, R over, right over. Now what is the left? Now what are the three nodes I have to consider? What are three nodes I have to consider? This is the impacted node. I have to consider 50, 60, 65 and do the left rotation like this. Second rotation you consider the reverse. Now here the 60 becomes the root, and 50 becomes child of this, 40 is there as the child, 60 has a 65 child, 65 has a 7 child. Now 55 is pending. Where 55 has to go? It comes this side here. This is again super balanced. This is 65 is. See, this is done. So we learned individual rotations. We applied on a set of data. We applied on set of data. Is this clear, guys? So this data I designed in such a way that it has to create a problem like this. Whenever I insert 80, I'm getting a RR issue. Whenever I get a 65, I'll get a RL issue. Like previous also we have done. 4 we understand. Exactly, Bikash. Exactly. That is how you do that. Okay. So now what we will do? We'll take last one example. One set of data I'll take. That only whenever I insert, automatically it has to cause different issues. So we do the rotations. Start with, we'll generate AVL tree. We'll generate AVL tree now. So I'll take the data like this. My keys are like this. First 70, then 30, 10, 50, 60, 35, and 80. I have these keys. Okay. First insert, start. Insert 70. Yes, done. Which is not causing any issue. Super balanced, right? One node only. Next 30. 30 comes left side. Okay. Next insert 10. 10 is causing problem, right? Insert 10 is causing problem. Which problem, which rotation you need now? Tell me. Which rotation, which rotation you need, guys? I'll take otherwise. This is step 1. Step 1, I am inserting. First 70 inserted, 30 inserted, no problem, 10 inserted. My 10 is causing the problem. Okay, 10 is causing the problem. So which rotation is required? Tell me. Rotation, actually LL rotation, where you need to rotate towards the right. Wonderful. So this is causing LL. I'm writing LL. Okay. Do the LL rotation. When you do the LL rotation, you are shifting towards the right. See the diagram. The right side you go. So right side you go means what should be the root, guys? Root becomes 30 and 70 this side. Left is 10. Balanced. Okay. Step 1 is done. Next you insert 50. 50 is there. So where 50 comes? Where 50 will come? I'll write this step number 2, guys. Step number 2, insert 50 and 60. So my above tree is like this. As of now, I have a tree like this. 10 this side and 70 this side. Okay. Now, which one? 50. 50 should be 50 should be left of 70. Yes, 50 comes like this. Is this causing any unbalanced? Is this causing any unbalanced? Is this causing any unbalanced? No. Fine. Next, inside a 60, guys. We have a 60 next. 60 means it should come a right of 50, right? Right of 50. 60, right? I think this is calling unbalanced. I think this is causing unbalanced. This is causing unbalanced. 60 is causing unbalanced. Which rotation is required now? Tell me. Which rotation is required now? Tell me. LR, wonderful. LR, guys, it is LR. So this is causing LR in this. Okay. So LR means two things we need. Two rotations. First rotation R1 and second rotation R2. First rotation is left, right? LR. First do left side, then do right side. So left side means what I have to do first? First I have to do left side. This side. After this, tell me. 30 remains same here. 10 remains same. 70 remains same. Any changes now? What should be change of 70? That is a 60, right? 60 comes here and 50 comes here. Now still it is not done. We have to do the, we have to do the, we have to do the, now you see which rotation, now you consider these three, which is causing unbalanced, important. Which node is causing unbalanced in this case? 70 also, I think, unbalanced, right? 70 also unbalanced, right? 70 is unbalanced. So you do the right side like this. Now it becomes 30 here, 10 here only, 60, 70, and 50. Okay. Next. I have only two more elements. The two more also will cause the problems. So third case I'll take. In third case, I will insert 35. I think 35 itself will cause a problem. We'll see that. First take the tree. This is the current tree we have. Current tree is 30, 10, 60, 50, and 70. So 35, where 35 has to sit. 35 will come in. 35 will come in. Left of 50, yes. Here is the, I think, which is causing unbalanced, right? Which is causing unbalanced. Which is causing unbalanced. Which is causing unbalanced. So you do the, what is that? This is right, left, left. Can I say it as LL? Can I say it as LL? So in LL, when you take LL, which three are taking the LL? 60, 50, and 35. 60, 50, and 35. Okay, this is 35 insertion is causing, guys. 35 insertion is causing LL. I do LL rotation. LL rotation means it's a single rotation, right? LL is single only. Now do a single rotation. LL means you have to shift right side. You do this. Right side you do. So 30 keeps there only. 10 here only. So here, what should be the child of 30 now? Here you will get a 50. And we have a 60. I think we done a mistake somewhere. Now again becoming unbalanced, see? Again becoming unbalanced. It should not happen. Maybe data I have taken wrong. Maybe the data I considered maybe the wrong case. Might be data is the use case I considered might be wrong. Okay. Okay, that's I'll stop there only, because again I can't do experiments in front of you. Data is considered as wrong. Okay. So I think you understand the rotations, guys, clearly, right? Yes. There's a AVL trees and all the rotations we have done. How to generate AVL trees also, just we have seen some cases. Maybe here I taken data wrong. That's what it is causing, or L. Instead of 35, for example, if I take as 80, for example, here I'll take 80. See, if I take 80 instead of 35, what happens? See, I'm changing this to 80 means it has to come left of this. I think now it is RL. This is RL, right, left. Now it becomes RL. I'm changing this. Just have a trial once. First 80 only I am checking. Okay. Now because of 80, it is becoming RL. So now what to do? RL means we have to do again a two-step process. First rotation towards the right. Which one I have to consider? Right means this you consider this. So the tree becomes 30, 10. Here is a 60, 50 here only. This becomes 80 cannot go there. 65 works, I think, not 80. 65 will take. So 65 means here it comes and 70 can come down here. You keep 65 here. 65, then 80. We are at 65. So right is over. Then we have to do left. So the second rotation you do R2 left. So in this case, 60 becomes the root. Then down to 60 we have a 30. Down to that we have a 10. And 60 down we have a 65. 65 down we have a 70. And 50 is there. Child of 60. 50 is there. 50 will go here as this. Yes, exactly. Now it is balanced. So the wrong data. 65 matching good. 65 is okay. Correct? 65 is, this place I changed 65. This is working good. Which is causing RL rotation. Here I caused a LL. Here I caused intentionally LR. Here I caused a RL. Okay, one more will finish it off. Fourth case. Fourth case will finish it as insert 80 now. Insert 80. This has to cause RR. That is my goal. We'll see whether it causes or not. What's the current tree, guys? Draw the current tree first. 60 I have. 30 this side. 65 this side. 70 this side. And here 10 is a left. 55, yes, 55 is the right. For this, I am inserting 80. So the node I am inserting here is 80 is the right of 70. Yes, 8 inserted. Definitely, which is causing the 1, 2, 3. No, this is not causing an issue actually. Now, this is balanced or unbalanced? So tell me, is this balanced or not, guys? 80 when I insert, it is balanced. 80 if I insert, no, it is a balanced. It is a balanced. So I had to do another work for this. After 80, again I'll insert 85. So 80 is not causing a problem. 80 is not causing a problem. After inserting 80, again I am inserting 85. Okay. Now, again 85. I think 85 will cause definitely a problem, right? 85 is causing a problem. Munna again asking how it is balanced. 80 is there, it is a balanced, Munna. See, if 80 is there, I inserted 80. Calculate the factor. Balance factor. 10, what is the 10 balance factor, Munna? The 10 balance factor munna. 10 balance factor. You answer it. 10 balance factor 0, 55, 0, 80, 0, 70. That 70 balance factor. 70 balance factor 1. And 65. Oh, 65 is causing guys. 85 not required. My misunderstanding. So always you have to recheck it. Calculate. This is really not required. 80 only causing a problem. What is the balance factor of 65? 65 guys. 0 minus 2 means 2. And balance factor of 60. 1, 2, 1, 2, 3. 1. This is 1, 1, 0. Is this? So you have a 65 unbalanced. 65 node becomes the factor 2, which is unbalanced, which is causing the problem. 80 is causing the problem. In this case, we have a very clear, because only 3 are there. Distance is this. So I think we can do it. It is a right happening. So 80 is causing right rotation, guys. Right rotation is single rotation. Single means we can do in a one-step process. Right means you do the left rotation, guys. Left rotation means like this you do. Now, so 65 I'll take as a root, and 60 here, 70 here, 80 here. For a 60 we have 10 as a child. Sorry, 60 we have a 30 as a child. For a 30 we have anyway 10 and 55. Is everything covered? 3 plus 7 nodes are transferred, right? After that, you have to cross check the balance factor always. That is important. Leaf nodes balance factor 0 only. 30, 0, 1, 1, 0, 70, 1, 60. 60 is 1, 2, and 60 again becoming unbalanced. 60 becoming unbalanced, you see? Maybe my data mistake, guys. Somewhere we have use case. But when you write a piece of code, automatically, see, whenever you do insertion and deletion, immediately will update the balance factor of all the nodes. And wherever 2 is there, you can start doing the rotations. Okay? That's the case, guys. Or I did a mistake, I think. Rotation only. Wait, guys. Sorry. I did a rotation mistake, actually. Tell me mistake what I have done. That's what it is becoming unbalanced. Because I did a mistake, it is becoming unbalanced. Can you guess? The mistake I have done? Can you guess the mistake I have done, guys? See, now which 3 nodes you have to consider? Which 3 nodes I have to consider? I told always 3 nodes to consider. Which 3 nodes I have to consider? I consider wrongly these 3 guys. See, I consider wrongly these 3. That's what I did a rotation like this. Correct? So that is I do understand my mistake. I should not consider that. What I have to consider then? You consider these 3 only. You rotate these 3 only, guys. These 3 you rotate. So root will not change. Point is clear? Root is 60. That's what we got a problem. 60 child 30 is there. 30 child 10 and 55 is there. That is not changed. Clear. Now this you have to change. These 3. 65, 70, 80. Wonderful. Dena and Munna and Bikash. Yes, right. So what should be the 60 child? Tell me now. What is it? 60 child? 70, that's it. Middle of that. Then 70 child is 65, then it is 80. Yes, super balanced. super balanced. So we have generated AVL tree now. We've taken a sample data, something like this. We've taken a first 70, 30, 10, 55, 60, 30, 65 it is, 80 also causing. We intentionally created 3 problems and we have done all rotations, guys. When inside 70, no problem. 30, no problem. 10, yes, 10 is causing unbalanced. So I rotated. Next, I inserted 50. 50 is not causing any problem. Then I inserted 60, which is causing a problem. Then rotation done. I inserted 35 is not there. What I had to insert after 60? 65 I had to take this as 65 is causing a problem. So done a rotation. Next I inserted 80. 80 is causing a problem. Which are causing a problem? 10 is causing, 60 is causing, 65 is causing, and 80 is causing. So, and the problems are, I intentionally created 4 different, some cases LL, RR, LR, RL, all are. Okay. That's about AVL full story, guys. I hope you have full clarity on AVL trees. And any doubts on this? AVL trees? AVL trees are self-balanced binary search trees. The main goal of AVL is to keep the height minimum and to keep the height log n instead of n. Okay, because of that we do operations very fastly. If the tree is unbalanced, it may take more time to perform your search, insert and delete operations. And what is how to check whether tree is unbalanced or not? In the AVL trees, we are using a balance factor. What is a balance factor? Balance factor is difference between the left subtree height minus right subtree height. That should be always either 0 or -1 or 1. Or positive values means it may be 0 or 1. What is the full form of AVL? It is actually 3 scientists, 3 persons names, Munna. AVL. The names of 3 persons who developed this algorithm, who developed this data structure, this idea, those 3 guys, first letters, those are. I didn't remember their names. I read very long back. 3 scientist names. Yeah. Yeah, like GOF, 3 guys. Suppose if Munna, Abdul and Bikash developed this, Munna, Abdul and Bikash, MBA, like that. MBA, Munna, Bikash, Abhilash, something like that. There is a name for A is there, AVL. 3 guys names in this combination. Okay. That's about AVL trees, guys. In the next session, we will see the red-black trees. Red-black trees, most important. But most we will use industry as using AVL trees and red-black trees, but most commonly red-black trees are used than AVL trees. We'll do that, yes. Tree maps and tree set in Java is using the, no. Tree set and tree map in Java using the red-black trees. Abdul is a red-black trees, not AVL trees. Okay. So red-black trees we'll see in the next session, guys. Thank you. Have a nice day.